So we're asked to graph the red function, which you might not immediately see, but if you move this around, then you can see the red function. Let's see what we're supposed to do with it. Given the graph of y equals f of x, drag the green movable points to draw the graph of y equals negative f of x. So you can think of this with some points, right? So if you were to plug in x equals negative 4, you get out y equals 1 on the red function, right? So if you were to multiply every result by a negative sign, then instead of getting y equals negative 1, you should get y equals positive 1. Right? So that's negative 4 comma 1 for y equals f of x for the red dotted line. For y equals negative f of x, we've just multiplied the y coordinate by negative 1. So I moved it down here. Let's do that for another point. Actually, this is 0 for y, right? So that should still cross at 0. We're going to make that. That looks like that's going to cross. Like if you think about the red dot here, this is negative 3 comma 0. So the reflection should be also negative 3 comma 0, because if you multiply the y coordinate by a negative sign, that's a negative 1, that's going to make it still be 0. Maybe we can pick another point here. This point right here, let's do. On the red dotted line, we're negative 2 on the x. 1, 2, 3. We're negative 3 on the y. That's for y equals f of x. Now y equals negative f of x, that just means we're supposed to multiply the result by negative 1. So we're negative 2 on the x, 1, 2, 3 on the y. So that's our new dot. So that's in the correct spot right here. So pick some actual points on the red dotted line, and if it's y equals negative f of x, it just means you're multiplying the y coordinate by negative 1. So it's changing its sign. So this should be the graph. Let's see if we can get another one. You can use the same approach on this one too. Just note that it's negative x, so it's like you're changing the x coordinates. So like on the red dot, we're at negative 4 comma negative 2. So the function is going to actually be the same at positive 4 comma 2. So let's drag it over here, positive 4 comma 2. So at this corner here, it was originally negative 4 comma 2. Our transformation function, it's negative x. So if you were to plug in negative 4 in here, negative 4 makes it positive 4. And then the y value is still the same. It's negative 2. So you could check that with some other points here too. Like if you were to plug in negative 5 comma negative 2. Negative 5 comma negative 3 is a point. So that means positive 5 comma 3 is a point. And then over here, a red dot would be negative 3 on the x, negative 3 on the y. So if you multiply the x by a negative sign, that makes it positive 3. And then it's still negative 3 on the y, because there's no transformations happening to the y function. So what happens is that if you multiply the argument by a negative sign, so if you multiply the domain variable, if you multiply x by negative 1, then it's reflecting it across the y-axis. Okay. If you multiply f of x, the outside, if you put a negative sign up here, then it's reflecting across the x-axis up here. So a negative sign next to x reflects it about the y-axis. A negative sign on the outside reflects it about the x-axis. So we've seen something similar to this one. It's being reflected, so it's negative x. That means it's being reflected across the y-axis. It's like it's getting flipped over to the other side. So you could do it by looking at some certain points, like the vertex is at 4 comma negative 2. So our new vertex should be at negative 4 comma negative 2, because we're multiplying every x coordinate by negative 1. And then maybe check another point. We have another point on the red dot. It's at 5 comma negative 4. Now we should have another point at negative 5 comma negative 4. And we do. And here this is at like 3 comma negative 4. So negative 3 comma negative 4. Everything's checking out. Let's see, this one is about the x-axis, because we're multiplying by a negative 1, so we should be seeing kind of the opposite thing happening across the x-axis here. So let's use that same approach. 1 on the x, 3 on the y. Since all the y coordinates are being multiplied by -1, now we should be 1 on the x. The x doesn't change. But we should be -3 on the y. Okay? And then let's find another point. We have like 2 comma 5. So now we should be at 2 comma -5 because the y coordinates are being multiplied by -1.